students. So I want to clarify some key ideas here in our notes as we come into our test on um, the history of geology and events that can occur in the geologic timeline as well as amongst rock layers. So first thing I want to emphasize in your notes is again this idea of superposition. It is a complicated way of simply saying that we understand that rock layers are younger towards the top and older layers are towards the bottom because of how sedimentation works. Sedimentation, again, is just the slow dropping of mineral content across a plane from a body of water. Could be freshwater, is most typically an ocean, way back in history. Changes to those layers are faults, folds, tilts, etc., that we'll learn in the third section called disturbances. These are always after the rock layer has formed. So as we go forward, the four primary laws, like how this works, rules by which, like if you are making rock layers, gotta follow these rules. Number one, this is called Steno's laws, by the way. You know that rock layers are going to lay down horizontally. Okay, originally OG layer, it's going to go down flat like this. So even if in the future, the far future, right now, we see things tilted, folded, or off kilter, we know that this tilting is a secondary action to the original deposition or depositing of sediment flat. Okay, the thing that moves layers from basically 90 degrees or flat is some kind of stresses, some expression of energy. The next rule is the layers will be laid or deposited in a continuous line until they either run into something or weathering or erosion occurs. Recall from middle school that weathering and erosion are talking about either air or another physical object grinding away, mineral or metal, depending, or water eroding it away, water carrying little bits of it away. Okay, like you see along riverbanks or shorelines. Rule 3. Major changes to these layers are called cross-cutting. Option 1. You can get magma or super hot melted rock coming up through, melting its way through formed layers. Okay, so you can cut across layers by violent means, by melting your way through, or option 2, you can fault your way through it. You can essentially apply so much pressure to some other section of the layers that it'll pop, it'll break, kind of like a bone. It'll break along a certain line, and then all the layers shift down or up together. Okay, so rule 3, certain things can cut across layers, and there are intense expressions of energy again. 4 is called the law of inclusions, and I want to emphasize this word inclusion with a C versus intrusion with a T. Inclusions are some piece of another layer inside a younger layer. So you get two kind of occurrences. And remember that inclusions with a C are always older than the layer they're found in. This is an example of granite, which is an igneous rock. Okay, granite is wild. It's super hot. It's a result of magma cooling down. And so what happened here is this weak lime sandstone, that probably got deposited, I don't know, by an ocean at some point, is getting melted or was getting melted by this granite. So the sandstone is older, actually. The sandstone was here first, and then it got burned, bullied, melted by this igneous rock that, imagine this is a magma flow. And so these little burbles here are little bits of sandstone that just happened to not melt before the granite cooled down, or before the magma cooled down. Think of these like ice cubes in a soda that just almost melted away but didn't quite. So these are older than the magma or the granite around it. You can also see gnarly situations where you've got inclusions, let's say granite inside sandstone. The only way this happens is by this sandstone sedimenting or depositing around the harder, denser granite. So in this case, the granite was like Big Man on Campus, straight up melted its way through the sandstone, RIP sandstone, and left a couple of unmelted burbles as notice to everybody else. This situation is where the granite, like the lava flow happened, it cooled down, it solidified, and then it was exposed to the elements for some given period of time and started getting eroded by wind or water or what have you. And then the sandstone, like the sand was sedimented or deposited in the crannies, in the nooks and crannies of the hard granite. The sandstone did not grind its way through here. It just kind of lightly, kind of like a snow globe, lightly floated down and filled in all the nooks and crannies over time until it looks like there's granite inside the sandstone. Really, it's the sandstone infilled the granite here. Okay, but nonetheless, it means that the granite had to be there before the sandstone could infill it. Okay, so inclusions are older than the rock in which they're included, no matter how violent or how gentle the process. So I want to emphasize that a different term, there's intrusion and then there's inclusion and then there's intrusion. Intrusions are, let me come down here. Intrusions are when you get magma, melted hot rock again, coming up through cracks. Okay, so inclusion with a C is where you've got layers, older layers, either melting their way into younger layers or young layers sedimenting around older layers. Intrusion with a T means magma melted its way through a crack. In other words, inclusions with a C are older than the rock they're found in. Intrusions with a T are younger than the rock they're found in. Because this is, you can't melt your way through a crack until the crack forms, right? Until the layer that cracked formed. So I really want to emphasize that. I felt like I did not nail that down. Okay, that's first. Then let's go back to kind of section C, or 3 disturbances or disruptions to rock layers in general. You can fold rock layers. So wild factoid for today, fam. The Earth's crust is a fluid. It flows just incredibly slowly. Everything is, including the atmosphere. Go ahead and chew on that. Enjoy your YouTube splunking. Anyway, you can fold rock. You can fold Earth's crust with enough pressure and with enough time. So if you look along mountain ranges like the Rockies, holy buckets. There's a lot of folding happening because there's a lot of pressure along that plate line. Folds are when the rock layers, multiple rock layers, buckle and bend due to compression stress over time, millions of years, hundreds of millions. Faults are when you get a straight up break, a mass break across multiple layers. So you read this, you can see like this dark line, all this looks like it seems to have shifted down. So all these layers formed, and then something happened where maybe this one popped up or these down. You've got infill up here that's most recent, but you see clear, just nice geometric lines across multiple layers. That's a fault line. Usually it's along tectonic plate faults where you get massive amounts of stresses, but sometimes you can have them a little more internally. Intrusions, again, are like we talked about when magma or hot melted rock seeps its way into existing rocks and then cools down into existing cracks specifically. And then last is a tilt. So pressure from below causes a section of the Earth's crust to pop up And instead of being nice and horizontal, which is how I originally laid down, it's now at an angle. Okay. Other things then to quickly touch on, unconformity. This is simply when you find uneven layers in the, like in a cross section. What happens is that some amount of erosion in the past just removed some of that rock layer, and so it's all gnarly and uneven looking. If we're lucky, we'll find an index fossil, but that's a different idea. Okay, so unconformity is a non-conforming, unusual, not smooth rock layer. And then usually there's sedimentation that happened on top of that. This indicates some sort of break in time. There are multiple layers contacting each other, and there's erosion. So instead of always just sedimenting, at some point we stopped dropping sediments and actually was exposed to air and lost mineral material, after which then maybe a body of water came back into that area tens or hundreds of millions of years in the future and put down new sediments. All right, so right here, we see this section where this seems to have tilted. It's like Scotland. This whole chunk seems to have tilted and just started eroding away. It's uneven, it's gnarly. The soft stuff is where the divots or valleys are. The softer stuff got taken away sooner. And then over time, we started seeing new sedimentation again. So maybe shallow ocean infilled here and started depositing in these holes and then filling these layers in like so. Or like in here, you can see that this all formed. We sediment horizontally, lay down our layers, and then at some point the water receded or stopped sedimenting, and we actually just started losing bits of mineral content, eroding it away. After which then it looks like some body of water returned to the area and redeposited new sediments. Okay. Here's a slightly clearer drawing of these unconformities. Okay. You do not need to know the specific names of the different kinds of unconformities. If you want to know, cool, but you don't have to. Okay. The key is you recognize a squiggly line in the rock layer. It's uneven because at one point the sedimentation process stopped and it got eroded before sedimentation started again. Okay, I hope that clarifies some details as to processes that can affect and change or modify rock layers.